Good morning, everyone. So today we're going to talk a little bit about division properties and negative exponents. So let's take a look at our first example here. This is just the basic rule. When you have a base being raised to a negative exponent, it does not mean that you have a negative answer. What it means is that you need to take the reciprocal of the base. So over here we have an x, over here we have a 1 over x, and then you change the exponent from a negative to a positive value. So notice how this x went from really a numerator, because this is kind of like x over 1, to the denominator. So it switched places, and the negative exponent became a positive exponent. On example 2, notice how the x to the negative second power is on the denominator of this fraction. So we take the reciprocal of the base, so it goes from the bottom to the top and becomes a positive exponent. So we have x squared. So if we think about it, there's another way. I kind of have a little trick here. X is not happy where he is. He's on the bottom. And in order for him to become happy and positive, he needs to move to the top. Over here, x is very negative where he is. He's not happy here. He needs to move to the bottom where he becomes happy and positive. So it's all about changing places, taking the reciprocal of the base and changing the exponent to a positive. So we'll see how that applies here. There are many ways to do these examples, and in some cases I'll show you both ways. Notice how we are dividing like bases. When we divide like bases, we keep the base and we subtract the exponents. So 2 minus 5 is a negative 3. So we can think of this as, the A is not positive. The A is very negative here, and he's not happy. So in order for the A to become positive, we take the reciprocal of that base and change the exponent to a positive. So now he's switched from the numerator to the denominator where he's positive. Another way to think about this problem, same problem, a squared over a to the fifth, is thinking about just taking the difference between the two values. So the difference between the two values is 3. The difference between 2 and 5 is 3. And if I think about which one of these is more, 5 is more than 2. So I'm going to put the a cubed on the denominator because 5 is more. So take the difference and put the value, the positive value, where it is more down here. Okay, so same answer, just two different ways of thinking about the problem. So if we take a look at number 4 here, we have 2 divided by 2 to the negative third power. So the first way I can do this problem is first thinking about that 2 as being 2 to the first. I'm going to keep the base, and when I divide like bases, I subtract the exponent. So 1 minus a negative 3 becomes 2 to the 1 plus 3, or 2 to the 4th power, which is 16. Another way to think about this problem, and it's really all about personal preference here, is to first change places. This 2 has a negative 3 for an exponent. This negative 3 is not happy where it is. So I can take that 2 to the first and leave it where it is and move this to the top. It's negative, so it changes places. So I have 2 to the first times 2 cubed, and that becomes 2 to the 1 plus 3, or 2 to the 4th power, which again is 16. So you see how we get the same answer, just two different ways of thinking about the problem. Let's check out number 5. When I see 3 divided by 6, I'm going to think about just dividing coefficients the same way I always have. 3 goes into 6 twice. So I'm going to put the 2 down here. and I have x over x to the 4th power. All the way simplified, I can only have one x. So this is like x to the 1st. So again, I could think about it as dividing like bases. I keep the base and subtract the exponents. And that would give me x to the negative 3rd over 2, which is the same as 1 over 2x cubed. Or I can think about this problem a little bit differently. Still thinking about 3 divided by 6 is 1/2, but the difference between 1 and 4 is 3, and the 4 is more. So I can have x cubed here. And again, same answer, just two different ways of thinking about the problem. Okay, last one we're going to talk about right here. Again, dividing the coefficient, 10 divided by 2 is 5. And we have divide like bases. We are going to keep the base and subtract the exponents. So just be careful with the negatives. Negative 3 minus a negative 4 becomes 5a to the negative 3 plus 4, or 5a to the 1st power, which is just 5a. If I want to think about this problem a little bit differently another way, same problem, 10a to the negative 3rd over 2a to the negative 4th. If you don't like the negative exponents, you can change them right off the bat, so this still becomes the 5. I'm going to swap places for these. I'm going to put a to the 4th on the top and my a cubed on the bottom. So once they switch, the exponents go from negative to positive. And now it's just a matter of dividing my like bases. I keep the base, subtract the exponents. 4 minus 3 is 1, which gives me just 5a. And so that's a little bit about dealing with negative exponents here. So have a great day, guys. Bye-bye.